Yeah, I said you started recording.
Cool. All right.
Yeah.
Okay, so let me just kind of come up with one on the spot. Now, do you want? So there's one thing where I said that markets are Pareto efficient. Probably not going to test you on it if I'm being frank. Or do you want just like an example of, like where I give like the 6 payouts, like it was like the hawk, dove, and pigeon model?
Yeah, that thing, like where it was like one more in like Marshall or something. It was like one of those ones, yeah.
Okay. So let's share my screen. All right, so I have, let's say, payouts. So you have player 1, player 2 payout. Can you see what I'm typing?
Yeah. I can see the spreadsheet.
And so they're going to be like formatted player 1's payout and then player 2's payout. Let's do player 3. Let's add a third player for
Okay.
choosing giggles. All right. So let's say we have range of choices: hawk, dove, pigeon, eagle. Okay. And let's say it's a 4x2 graph. So in fact, let's not do a game theory matrix because then I'd have to do a 3-person matrix, and that'd be just visually hard to represent. So let's just write outcome 1. Let's do like that's not what I want. So there's like 8 outcomes. Okay. Give me a number, or let's do this. I'm doing a random number generator right now.
Okay. Okay.
All right, so we have player 1's outcome on the leftmost, player 2's outcome on the middle, player 3's outcome on the third one here. Okay, so I'm solving it live. You saw that I just did a random number generator, so I'm as close to this problem as you are right now. And just to demonstrate, or just to make sure we're on the same page, Pareto efficiency means that I cannot make player 1 better without hurting player 2 and 3. And likewise, I cannot make player 2 better without hurting players 1 and 3. And I can make player 3 better without hurting players 1 and 2. Right? Does that make sense?
Yeah.
So if I can find an allocation that improves one of the players without hurting another of the players, then it's Pareto efficient. Okay. I suspect because it used the random number generator that most of these are going to be Pareto efficient. Usually I do a random number generator and then I kind of tailor my numbers so that I can eliminate like half of them or something like that. Not half, but like eliminate a bunch and keep a bunch. Okay. So what I want to do is I want to compare outcome 1 versus all these outcomes. Okay.
Okay.
I want to stop them from random number generating, so I'm just going to paste them as numbers. So cool. And like this is a lot of work, but like what I'm doing is a lot of work relative to what you actually need to do. I just want to be as clear as possible.
Right.
But
Okay.
usually, like you can just kind of eyeball them and eliminate a bunch, but for the sake of complete clarity. Okay, so outcome 1 versus outcome 1. I'm just going to write an X because it's the same outcome. Okay.
Right. Yeah.
So these are verses. These are the verses here. So outcome 1 versus outcome 2 is how I'm going to read this.
Mm-hmm.
Okay. So 10, 1, 7 versus 5, 1, 4. Okay. So 10, going from 10 to 5 is a minus. Okay. Going from 1 to 1 is 0. Going from 7 to 4 is a minus. Okay. So
Okay.
I can't eliminate outcome 1 yet. Make sense?
Yeah.
But what I do notice is it's a minus 0 minus. So if I were on this square, outcome 2 versus outcome 1, I'm going to have a plus 0 plus, right?
Right.
So 5 to 10 is a plus, 1 to 1 is 0, 4 to 7 is a plus.
Right.
So I can eliminate outcome 2.
Right. Mm-hmm.
I'm going to get rid of this because it's like a large text. G minus 0 minus. Okay.
Wait, before we go along, just to understand clearly, we're
Mhm.
finding we're finding the best combination, or we're finding what the combination it would be that two players, well, I shouldn't say players, but I guess you could say that players lose out and one gains. So is it like one or two? Like, are we trying to find which one the best combination that all three players gain, or are we trying to find the combination where one player gains and two players lose? Does that make sense?
I don't understand your question. Let me see if I can rephrase it.
Uh,
So there's going to be a combination here where you add up all the numbers and you get a really high one, right?
right.
That doesn't necessarily mean it's Pareto efficient though. So if you have like 6, 6, 6, and oh, that's a bad example. 5, 5, 5. And 4, 1, 8. Wait, yeah, 4, 1, 8, and 6, 5, 5. Right. This
Mhm.
one is going to have a sum of 15. This is going to have a sum of 13. This is going to have a sum of 16. These two are both Pareto efficient. And the reason is, so even though this one has a higher sum than this one makes player 3 worse off than, like player 3 is better in this scenario than it is in this scenario.
Oh, okay. I see.
But this one is not Pareto efficient because player 1 can do better without hurting players 2 or 3.
Oh, okay. I see. I see now. Yeah,
So
that
even though
answers.
this is the lowest overall utility, it's still Pareto efficient because any other allocation will hurt player 3.
I see. Okay. Yeah, that makes
What
sense.
what you can do immediately actually is you can find the best that so the best that like the maximum of any player. So let's say player 1 has their max is 10. Unless you see 10 somewhere else, that is automatically Pareto efficient.
Okay. That let me write that down in my notes. Okay. Yeah, that answers my question then. I was just a little confused on the term, but that makes sense now.
Okay.
Okay.
So I'm going to write can eliminate outcome 2 because outcome 1 is better for players 1 and 3 without hurting player 2. Okay. So I'm going to strike this. And I'm going to strike all these. So we don't have to worry about outcome 2 anymore.
I see. Mm-hmm.
So we can ignore outcome 2 when we're doing our elimination from now on. Okay, let's take a look at outcome 3 versus outcome 1 versus outcome 3. So I have a 0 going from 10 to 10. Going from 1 to 2 is a plus. Going from 7 to 1 is a minus. So I have a minus there, so I can't eliminate. Let's do outcome 4. Why are they all 10s? Hardly seems that random, right? But,
Yeah.
so outcome 4 is 10, 9, 4. So I have a 0. I have a plus, and I have a minus. Okay, so that's good. 10, 7, 2, same thing is going to be 0 plus minus, right? 2, 9, 8 is going to be a minus, plus, so 10 to 2 is minus. Make sense? So
Yeah.
player 1 loses going from outcome 1 to outcome 6.
Yeah.
Player 1 gains, player 2, player 1 loses, player 2 gains, player 3 gains, going from 7 to 8. Okay, so this has a minus, so you can't eliminate it. Okay, what about 6, 1, 6? So I should have a minus, 0, minus.
Right.
Minus, 0, minus. Okay, what can I say about outcome 6? Or I'm sorry, outcome 7?
Outcome 7. You can get rid of that one, right? Because 2 lose. Well, it really doesn't matter because none of them gain anything. Is that right?
No, so going from outcome 7 to outcome 1, so player 1 gains, right? From 6 to 10.
Right.
Player 2 stays the same. Player 3 gains.
Okay. Wait, let me.
Sure, take your time.
One sec. But isn't it a subtraction when we're looking at it from 1 to 7?
Correct. So you cannot eliminate outcome 1 because it's got the minus there. So we can eliminate anything with only pluses and zeros. Cannot eliminate anything with minus.
Oh, then I see how you've been getting there. Okay. Let me write that in my notes. Can eliminate anything with only pluses and zeros. Can only. Okay, that makes more sense.
I guess technically, if everything is a 0 and there is no other Pareto efficient outcome, then, like, if there's no better outcome, then you can't eliminate that. So if it's like 0, 0, 0, so if you have the same two outcomes, they're either both Pareto efficient or both Pareto inefficient.
Oh, okay.
That's like
Yeah, then I get. Yeah, I was a little confused there, but I get where you're getting at there now.
okay. Right. So We're going from outcome 7 to outcome 1 real quick. So I'm going to have a plus going from 6 to 10, 0, and then a plus. Going. Nope, I do not want to accept that correction. Okay. So it's got only pluses and zeros, so you can eliminate it. So what it means to have only pluses and zeros is that I'm making a player better without hurting another player. That's like the shorthand for it.
Okay, that makes sense.
So I'm making players 1 and 3 better without hurting player 2.
Right.
So now I no longer have to care about outcome 7. Okay. So let's just hide it, in fact. Okay. So outcome 8. So going from outcome 1 to outcome 8, how does player 1 do?
They lose 7,
Mm-hmm.
and
Player 2?
then they gain
Okay.
3,
Okay.
and then player 3 gains 2.
So can you eliminate?
No, because there's a minus.
Okay, and what does it mean to have a minus in like words?
One has to lose for the others to gain.
Right. Exactly. So
Okay.
outcome 8 is not, or sorry, outcome 1 is not eliminated. There's nothing that eliminates outcome 1. Right. So we can say that outcome 1 cannot be eliminated. So therefore it's PE, Pareto efficient. Okay. So it's Pareto efficient because there's no other outcome in which one of the players gains and the other players don't lose.
Okay.
There's outcomes in which all players gain. Or sorry, there's outcomes in which the opposite is true, where players can lose without another player gaining, right? That would be outcomes 2 and 7. So those are not Pareto efficient because we found, so like standing from outcome 2 there and going to outcome 1, players 1 and 3 gain and player 2 doesn't lose. So we can eliminate outcome 2 because we have found an allocation that is better.
Okay. Yeah. Okay, that makes sense. Yeah.
Okay. So 10 to 1. Okay, so going from 10 to 10 is what?
0.
Hmm?
10.
2 to
Yeah.
1?
Is 1.
Oh, sorry, plus or minus 1?
Minus 1.
Mm-hmm. Sorry.
And then that one's minus 6.
From 3 to 1, we're looking at outcome 3 now.
7.
So we're going from outcome 3 to outcome 1 now.
Oh, that's 6.
Plus or minus?
Minus 6.
Try again.
Plus 6.
So
Wait, why did we do the minus for the middle one, but plus? I think that's where I'm kind of getting confused here.
So standing at outcome 3, so let's say outcome 3 is what the real world is. Okay, you're player 2 in outcome 3. Do you gain or lose if they go to outcome 1?
Oh, you lose.
Right. If you're player 3 in outcome 2, or sorry, player 3 in outcome 3, do you gain or lose if you go to outcome 1?
Oh, you gain.
Right. So that's why it's a plus.
Oh, okay. I see now how you're getting this. Okay. So one outcome 3. Okay, let me try doing this one.
Okay.
So we're doing outcome 4 to 1.
Oh, I'm sorry. Yeah. Outcome. We can't compare outcome 3 to outcome 3. So yeah, outcome 4. So we're starting from outcome 3. We're comparing it to outcome 4.
Okay, so 10 will remain the same, so 0.
Mhm.
If your player 2, you went to put outcome 3, you would
No,
lose.
you're starting at outcome 3, going
Oh, you
down.
outcome 4.
So we're right now. It's kind of confusing the way I laid it out, I guess. But we're looking at outcome 3, and we're going to compare outcome 3 to all the other outcomes.
Okay, so that one would be you would gain 7, so you would
Mhm.
gain, and then you would gain 4, so you would gain 3, so you would gain.
Okay. So what can you say about outcome 3? Can you say it's a Pareto efficient or not?
It's not because
Right.
because you can't gain without hurting someone else.
Try again. I think you're there, but I think you misworded it.
You can't the one player can't benefit without hurting the other two. Is it like that? Kind of like
So
I get like where
going from
you're getting
outcome 3 to outcome 4, does any player benefit?
two players benefit, but one stays the same. And
Right.
that
So
would
can you
be
make somebody better off without hurting the other people?
oh yes. Yeah,
Right.
yeah, because no one's getting hurt. Yeah, yeah, yeah.
So because you can make somebody better off going from outcome 3 to outcome 4, that's why outcome 3 is not Pareto efficient.
Okay, okay. Oh yeah, yeah, yeah. Okay, yeah, yeah. Sorry, it like takes a little bit to just get this.
It's like a mad confusing definition in my opinion. Like it took me a while too, so don't like worry, don't think twice.
Okay.
You're not the only person who's been like confused by Pareto efficiency. So going going to outcome 4 improves players 2 and player 3 without hurting player 1. So outcome 3 cannot be PE. Does that make sense the way I worded it?
Mm-hmm.
So I'm going to hide outcome 3. We no longer have to consider outcome 3.
Okay. Okay.
So let's start with outcome 4 versus outcome 1 now.
Okay. And we're comparing outcome 4 to 1, right?
Yep.
Okay. So I'm playing 0, -8, and then you gain. So we can keep that because there's a negative.
Right. Okay. What about
And
versus this is outcome 4, so you can this is comparing the same thing versus the same thing. Now outcome 5.
okay, and we're comparing outcome 5 to 4 just to make sure.
Yeah, so we're starting with outcome 4, going
Mhm.
to outcome 5.
Oh, okay, okay. So 10 is still the same, so it's 0. Whoops. 9 to you lose,
Mhm.
and then 4 to you lose.
Okay. So can you eliminate outcome 4?
No.
Okay.
Yeah, no, no. Okay.
So outcome 4 versus outcome 6 now.
Okay. 10. You lose.
Yep.
Um, 9 gains. Well, I'm sorry, it stays 0. I'm sorry, 0. And then 4 to 8, that's gain.
Okay. Can you eliminate outcome 4?
No.
Okay. Sorry. Okay, outcome 4 versus 8.
You lose. You lose. So negative, yeah, sorry. And then you gain.
All right, so we've now compared everything versus outcome 4. Anything that can make both or any player better without hurting another player?
No, not that I see on the board. No.
Okay. So can we say it's Pareto efficient or no?
Yes.
So far we have outcome 4 and outcome 1 are both Pareto efficient. And we've eliminated 2, 3, and 7. Okay. Outcome.
Yeah.
Okay.
No, I was just gonna say now this is starting to kind of make more sense to me. Okay.
Why are they all 10? How many did we do that with 10 so far? I just want to see real quick. So 4 out of 8. So there's a random number between 1 and 10. So there's a 1 in 10 shot that any number is 10. So I just want to do the math on this. So it's 0.1, right? 10% to the fourth, that 4. So 0.1 to the fourth times 0.9 to the fourth. Never mind. I'm sorry. I was geeking out for a second, but it's not very likely. Let's go back to, so now we have outcome 5, okay, and we want to see if outcome 5 is Pareto efficient. So we're going to compare it against 1, 4, 6, and 8.
Okay.
The remaining
So
allocations.
right. So 10 is 0.
Mhm.
7 to 1 is less, so negative. And then 2 to 7 is a gain.
Okay. Can I eliminate?
No.
So then outcome 4.
Outcome 4. Yeah. Sorry. So that's gonna be 0 still. Gain and gain.
Okay. Can I eliminate?
Yes.
So also, I noticed this actually earlier. So is this? Oh, sorry, my thing's in the way. 0 minus minus. So when you have a 0 minus minus or a minus minus minus, or like minus 0 0,
Mm-hmm.
then you know that the flip side of that is there's going to be an allocation that's plus 0 plus or plus plus 0 or something like that. So the other allocation could basically be eliminated. But does that make sense? Let me
The
show you.
math makes sense, but just kind of explain it.
So these two are like this is outcome 4 versus outcome 5. This is outcome 5 versus outcome 4. The flip side of 0 minus minus is 0 plus plus.
Right.
So if I only have minuses and zeros, I can't eliminate the one I'm starting with, but I can eliminate the one I'm comparing against.
Okay, yeah, no, that makes sense. Yeah, I was like, the math makes sense. I just had to see a visual of it.
Mm-hmm. All right, so we're down to our last two. Okay, so this is outcome 6 versus outcome 1 now.
Outcome 6 versus outcome 1. Okay. Gain,
Mm-hmm.
loss, and loss.
Can I eliminate?
No. And
Now this is
then
outcome 6 versus outcome 4.
gain, 0, and loss. So we can not get rid of that.
Outcome 6 versus outcome 6. We can't do anything with that. So last one, outcome 6 versus outcome 8.
Outcome 6 versus gain, loss, and then gain.
Okay, can I eliminate?
No.
Oh, sorry. What is this? Outcome 6. All right, and then last 3 versus 1.
Okay, yeah. Gain, uh, loss, and then loss.
Hmm.
And then 3 versus 10, gain, gain, loss.
Okay.
And then loss, gain, loss.
Okay. Can I eliminate?
No, you cannot.
So we have 4 Pareto efficient outcomes. So it actually worked out that it was half and half, believe it or not. But yeah, there you go.
And these would be all. Okay, yeah, no, I see it. And I'm just like analyzing this. I don't know if it would be a question, but wouldn't like if this makes sense, like certain ones like outcome 8 on sorry, I'm trying to explain this the best way so I'm not confusing you either. But if you look at outcome 8 going down across outcome 6, no, I'm sorry, outcome 8 going down across outcome 4 where it's negative, negative, plus. Well, it's sorry, I'm really trying to figure this
Over
out. How
here.
to yeah, right there. Yeah, you got it. The like those ones where it's like a negative, negative, plus, wouldn't that be more Pareto efficient than like let's say a plus 0 and a negative or a plus plus and a negative? I'm just like analyzing this. I don't know if it would be a question.
So the question is minus minus plus more PE than, what was it? Plus plus negative?
Yeah, plus plus negative or 0 negative plus. Does that make
Um,
sense? I'm like just analyzing it because I'm thinking like in the negative negative plus 2 people would lose, and then versus like in a plus plus negative or 0 negative plus.
I get what you're saying. So imagine a world where Jeff has Bezos has this much, okay, and Martin has this much. Okay. Uh, and then imagine a world in which Jeff Bezos has exactly half of that, and Martin has half of that. You might say that this one's more fair, right? I would
Hmm.
more fair. Like you can't afford to live on $0.0001, but
Hmm.
and Jeff Bezos doesn't notice when he gains $100 here or there, right? Um,
Hmm.
but like the definition of Pareto efficient is essentially that if I have to take from Jeff Bezos to give to you, then it's not Pareto efficient.
Oh, okay, that makes sense. Yeah, I see. Okay, that makes sense.
So it's fairness blind, essentially. So even though like this one does better, this allocation does better than this one here on for 2 people and only hurts one person. The fact that it hurts anybody makes it not Pareto efficient.
Okay, that makes sense. Yeah, I was just like looking at it like I was just analyzing it. Okay, that makes sense though.
What you might say is that this one has lower deadweight loss, so it might be more like allocatively efficient.
Yeah, I see how that
Um,
would be.
but it, like Pareto efficient by definition is if you have to hurt the other player to or hurt another person in order to make yourself better off, then it's not. Then it doesn't work.
Yeah. Okay, that makes sense. Uh, yeah, that's really all the questions I had. I didn't have too many. I just wanted to understand that more. And like
Sure.
you'll be able to share this just so I could go over it again.
Yeah, I'm gonna post this online. I'm probably gonna have another review session on. I'm angling towards Saturday, honestly. Um, I don't know if anybody will come, but what I want to do is tonight I'm going to write up the final and the final practice that'll look like the final, and then on Saturday I'll make it. I'll do the review session, or maybe like Sunday night or something, whenever the Eagles aren't playing. Um, and I'll have the review session or the extra credit due before that, and then we can go over the answers.
Okay, awesome. Cool.
I prefer Saturday. That way you have enough time to view the video before the final. But I'll make an announcement. I'm not really sure what I'm doing exactly, even if I can even do this, because I'm behind on everything right now. So we'll see. But I'm
Okay,
gonna try to have another at least one more like office hours at the very least for people with questions.
okay. Thank you.
Of course. All right.
Have
Have
a
a
good
good
night.
day. Good night.